if I walk normally, watch. Like this.
For this project, I looked into something small but very important in the retail world: security tags. You probably set one off by accident before or brought one home still clipped to your clothes after shopping. I chose this topic because I've always wondered what was inside of them, and it turns out they're way more complex than they look. So there's two main different types of security tags: the ink tags and the RFID tags. The ink tags are more of a deterrent. They don't trigger alarms, but they just make a mess if you tamper with them. The RFID tags are high-tech, and they trigger the store alarms if you pass through the sensors without removing them. The RFID tags contain a microchip, a copper antenna, and a locking pin inside a plastic shell. The chip communicates with store sensors using radio waves, which is how they detect theft. Usually you can tell which devices are the ink devices and which ones are the RFID ones that will trigger the alarm by looking at them, because the ink vials, you can see the ink on the outside and they'll have like a warning on them, but they're both similar in that they both have a spring lock pin, and they use that to attach the clothing so that you can't remove them without the detacher. And that's pretty much where the similarity ends, because the RFID tags trigger alarms, and it sometimes can be both, but usually it's just one or the other. And in this presentation, I'll be mainly focusing on the RFID tags because they are a lot more complex and there's a lot more to talk about.
There is a fast and easy way to remove these if you want to avoid a trip back to the store. It only takes a few moments, and all you need is a powerful magnet. Simply hold the magnet to the bulging portion of the tag while squeezing the two halves together. As you can see, it comes right off. The mechanism inside is very simple. It's just a spring-loaded plunger that locks onto this serrated pin. In fact, if I put the magnet on it, you can hear that plunger going back and forth.
So there's several different designs of these. This is one that I got from Target, and I took it off my bathing suit with forks because I forgot to take it off. And then I made my dad open it up so I could see what was inside. So here's a closer look at it. This is the plastic parts. This plastic is hard ABS plastic, or they use polycarbonate. It's super durable and tough and doesn't shatter easily, so it's hard to open or tamper with it. And then this is a stainless steel pin. So they use stainless steel because it resists bending and corrosion, and it's sharp enough to pierce the clothes without damaging it. So this part, basically there's like a hole here, and then the pin goes here, and that's how it locks on the clothes. And then these springs in this pin are part of the locking clutch, and these are also made of steel, and it helps to grip the pin and like hold this together so that you can only open it with a strong magnet, or you can smash it open if you really want to. And then this part is a part that actually makes the alarms. It's kind of hard to see, but there's like the copper coils in there. Those are the radio frequency coils, and they're made of copper. This interacts with the security gates at the stores, so whenever you pass through them, the alarm will go off. And you can see in there, there's like that little wire piece. That's where the power source is kind of connected. So the outer shell is made of plastic, the ABS plastic, which is a shatter-resistant polymer, and it starts with crude oil. So they extract it from underground or under the ocean, and they refine it in large facilities. And then it's cracked up into smaller molecules, and they turn it to plastic pellets, and then they can mold those to make the hard shell for the tag. So the mixed material is steel, which is mined from countries like Australia, Brazil, and China. The pin and the internal locking parts are made of steel. So it comes from iron ore, which is mined from the earth, and then they smelt it at high temperatures in the blast furnaces, and they mix it with carbon, and it turns into a strong steel. And then after they have the steel, they're able to cut it with the precision cutters into the pins and the springs to create the locking system. And then the last material is copper, which is from places like Chile or the US. They mine it, and then they have to crush it, purify it, and smelt it in the super hot furnaces. And then they're able to extrude it into thin copper wires, which those will act as antennas for the part of the alarm system. All the materials that they picked for this device have a purpose. Copper is one of the best conductors of electricity, so it works great for antennas. And then ABS plastic is durable, cheap, and radio transparent, so that the radio signals can easily pass through it, and it won't be easily tampered with. And then spring steel is nearly unbreakable when coiled, so this makes it super secure and helps keep the tag locked on the clothing item. So now we know what they're made of and where the materials come from, but what happens when the stores are done using the tags? Most of the time they're reused, so they can go back to the store supply center and they get tested and put on new clothes. But if they break or the battery dies, that's a problem. So since they have mixed materials like plastic, metal, and electronics, that makes them really hard to recycle. So they end up in landfills, which contributes a lot to e-waste. This project really helped me realize how much science goes into everyday items and how complex the things we use every day are. It also connects to what we learned in class about sustainability, recycling, and plastics, and how products are made. And then also, one fun fact that I learned is that the copper in one of these tags, the copper coils, they can send signals up to 3 feet away. And that's how sensitive the systems are in the stores.